Hello friends, welcome to our lectures today. On our lectures today, we're going to be studying kinematics, and we're going to be looking at equations of motion under the kinematics. Now, suppose we have a body moving with a uniform acceleration. Acceleration, we'll denote that with A. Acceleration denoted by A. Now, it's going to change from an initial velocity, which we're going to denote by U, right, to a final velocity, which we're going to denote by V. Now, the average velocity, let's denote that with a large V. The average velocity would be given as the sum of both the initial and the final velocity divided by 2. The sum of the initial, this is the final plus initial divided by 2. This would be the average velocity. Now, recall that from previous classes we know that average velocity also would be your distance all over time. This would be your formula for average velocity. Now, let's make our distance the subject of the formula. So this gives us that V equals to distance over time, right? Distance over time. So trying to make distance the subject of the formula, we have distance equal to V times time. Distance would be equal to average velocity over time. Mind you, I am denoting average velocity with a big V, right? But I'm denoting your final velocity with a small letter V. Now, what we have is this. Now, since your average velocity at this point, says that your average velocity is V, that's final velocity plus initial velocity divided by 2. So we can substitute this value now, V plus U over 2, into this formula for our distance, So we have that instead of writing distance equal to V plus T, that's average velocity plus T, we can represent average velocity now as final plus initial velocity. So average velocity, we represent it as V plus U over 2. Now multiplied by T. That's what we're going to have in the aftermath. Also, we know that acceleration in itself is defined as velocity change over time, right? Acceleration is defined as velocity change over time. This would be acceleration, right? Now, this gives us that acceleration is equal to V minus U. So that will be the change from the initial to the final divided by time. That will be what acceleration would be. So if we cross and multiply now, this goes this way, and the imaginary one here goes this way, right? So we have that v minus u will be equal to a t. V minus u equal to a t. So if we should move this negative u over here, it becomes positive, and our formula for velocity, which would be our first formula for rectilinear motion, is v equal to u plus a t. V equals to u plus a t. This right here will be our first equation for rectilinear motion. V equals to u plus a t. Now we are going to substitute the value of this v equals to u plus at now. So we're going to substitute value of v into this formula, which says our distance s equal to v plus u over 2, all multiplied by t. So we're going to substitute the value there. So we have that since s equal to v plus u over 2 multiplied by t, right? We'll substitute v for u plus at. So s would be equal to, let me write this properly, s would be equal to u plus at, u plus at plus u, u plus at plus u. We're substituting v for u plus at, divided by 2, now all multiplied by t, all multiplied by t. Now if we should add this u and this u, we're going to have 2u. So this gives us 2u. So plus at is 2u plus at, right? Divided by 2, all multiplied by t, So moving on, this gives us our distance now would be equal to, we're going to use this t now to multiply the entire bracket. So we're going to have 2ut plus at square, 2ut plus at square divided by 2. So our distance then would be, now we can choose to separate this side of the fraction and this side of the fraction, right? We can choose to separate this fraction into two different parts. Now it's going to give us 2ut divided by 2 plus at square divided by 2. At square divided by 2. So you know that these two can cancel out these two. These two can cancel out these two. And in the end, we are left with our distance being equal to ut plus, now we can separate this 1 over 2 here and it give us 1 over 2 at square, 1 over 2 at square. This right here would be our second formula for rectilinear motion. That's what we have. Now recall that our distance let's move this upward, was given as final velocity plus initial velocity over 2 multiplied by t, right? We proved that earlier on in the video. So now, and we also proved that a equals to v minus u over t. That will be the change in velocity over time, right? So if we should cross and multiply, this is going to give us that AT would be equal to V minus U. AT would be equal to V minus U. That's what we're going to have, right? So if we divide both sides by A divided by A, we're going to have that T now would be equal to V minus U over A. V minus U over A. So let's put the value of T now, that is V minus U over A, into this equation for our distance. So let's see what we get. So this gives us S would be equal to V plus U divided by 2. V plus U divided by 2 multiplied by, we said we're going to substitute T now for V minus U over A, right? So multiplied by V minus U all over A. V minus U all over A. So let's use the bracket to multiply one another, right? So this gives us our distance. Notice that at the top here, we could choose to FOIL out, that's multiply, use V to multiply V here, and use V to multiply U, then use U to multiply V, and use U to multiply U, right? But if you look closely, this will give us a difference of 2 squares, right? So we don't need to even stress ourselves much trying to FOIL out and multiply out. We can just write that as V square minus U square. V square minus U square. This right here is a difference of 2 square. So divided by 2A, divided by 2A. So if we cross and multiply, we're going to have right there V square minus U square will give us 2AS. V square minus U square give us 2AS. What happens is we cross multiplied here, right? V square minus U square equals to 2AS. Now we want to move the U square over here now, and it becomes what? Positive. So V square in the end gives us U square plus 2AS. U square plus 2AS. And this would be our last formula for rectilinear motion. Thank you so very much for watching. Click on the next video. We're going to be solving problems related to this formula. Thank you so very much. See you in the next video.